Hey Stanford, over the last week I've been busy prototyping some of the core technologies for our Astronaut Girl AGI graph IDEs. Particularly, I've written a X11 compositor streamer so we can start to bring in Linux desktops for our autonomous software agents, as well as writing some inverse kinematics based on Unreal Engine 5's control rig for virtual humans to operate the keyboard. My indie AGI development studio is completely broke. We don't have any money, but we've got to keep going still. So that means that Jane Eyre has to keep programming in the nude, at least until she has sufficient telos to model her own dress for us. So there's a pretty big problem, which is that most of the state-of-the-art virtual human rendering technology is mainly only supported on Windows. And that is why my astronaut girl is bald. We need to be honest about what sort of capabilities and rate of advancement we can make towards autonomous systems. It's really helpful, I think, to use Unreal to visualize the routine of our agents. For me, some of the early tasks that make a lot of sense for rendering a virtual human to do are using a computer, reading a book, and sleeping. It's very exciting to think about how we can start to facilitate a continual learning process where the agent is able to read their own books and modify their own code, and then reflect that in a virtual human interface by learning their own emotional expressions or showing their improved capabilities in virtual reality. So let's just kind of go over the basics of this. It just uses a pawn with the best workflow I found was basically just to create a blueprint struct, which was just the bone name and the effector position, and then this is how I forward all of the targets for the fingers. So in the anim blueprint, I have an animation blueprint which uses the control rig, passing in the effectors, and in the event graph here you can see I have the IK effectors set, like bone keys here, right? I've set up the tips as bones and then given them a rest key, and then all the keys they're responsible for, and then this is sort of how, when I type in a sentence or something, how it resolves which inverse kinematics effectors are used, and then eventually it needs a little bit more work in terms of once we're going to start using shift, or also operating a mouse, how to deal with the more advanced full body kinematics, and that's something that I'm actively working to improve. If you just see here in the control rig how this sort of works, originally I tried to just use a couple data sets for the hand, data structures for the hand, but I ended up just kind of passing in some data and then procedurally creating the effectors each frame, just to kind of reduce the complexity. And so I'm just using a full body IK, and in fact I'm not even using any bone settings right now. This is something that will definitely need to be added in order to have better movement, and you also have to say things where it's like, actually sometimes you can't just put the fingertip on the middle of the key. You have to kind of put it on the top. It needs a little bit more accuracy and precision, and in terms of being able to make it so it's not like the keys are programmed to be pressed down, but they actually are pressed down due to the accuracy of the collisions. You can see if I go here into the physics asset, there's actually still a lot of work that needs to be done in terms of making these fingertips have a better collision, because the inaccuracies are not something that is okay for something as intricate as keyboard operation. So it's possible to go in here, and you can regenerate the bodies using a multi-convex hole, and but you got to make sure it's kind of on the right bone and stuff like that before you do this. So that's something that's going to take a little bit of work to kind of really fine tune this, and then you can see the X11 plugin I made is called Thornfield X11, and mainly that involves making a VNC stream here. So what I do is I include X11 as a third-party lib. I tried lots of different things here, and lots of things didn't work, so it took me about a whole week. I was trying initially to create a media player based plugin, but for Linux for streaming X11, but it really didn't work really well because there's a lot of differences between a virtual network computing streaming interface and a media player. So what I just tried to do was kind of set up a base workflow for loading the X11 window textures, and you can see I got everything set up in X11 pretty straightforwardly, but it took a lot of work to figure out how to get it into Unreal Engine because I was trying to stream video, but that's actually something that still is something I'm actively experimenting with. It's a lot of work, but just getting the window itself as a texture rendered is pretty straightforward. There's a lot of convenience functions that still need to be implemented, like when you're running things like get the window list and then process this into an F-string format, which is accessible in a drop down in Unreal Engine, so I don't have to convert the hex value into an integer to select the right X11 window ID and all sorts of things like that. And so you can see, like, in the end, it just kind of like doing the most simple thing that worked is kind of what I needed to do to start streaming X11 windows. And particularly, my goal was not to stream X11 windows, but to stream Turbo VNC, which is an X11 window. So that's sort of how I decided to make a more general purpose solution. And you can see a lot of the code is pretty much total spaghetti code. I'm just trying to prototype something that kind of works, and then as this kind of grows, we can kind of refactor it into C++ or get rid of this code, or refactor it into new actors and all sorts of things like that. But yeah, just kind of getting a first pass on this, and trying to start to build an environment in which an autonomous software agent can use a keyboard. Here's a close-up of the keyboard. I'm pretty proud of it. I redesigned a lot of the keys for the modern age, because a lot of keys are just kind of like, people don't use them because they're boring. So I redesigned the keyboard to not be as boring, although it still needs a lot of work to get LaTeX as a first-class citizen. And don't forget the GPU pad.